Hello friends, welcome back to this series of Python. And from today onwards, I'm going to start about the Python library. We will discuss one feature every video in this Python library series. So it will be around 10 to 15 videos for the Python library. So today we are going to discuss about the hashing. Well, hashing, you might have heard about the hashing in case of algorithms. If you have studied about the data structures and algorithms, you must have an idea about the hash functions and hashing, how it works. So this is a small picture, and here I can show you that the values are stored inside a table, and that table has an index and an associated value with that index. And there are hash functions. These hash functions, what they do, they simply take one key and calculate the index based on the value that hash function returns. Based on that, it returns an index for this storage table, and the associated value is stored at that particular index. It may be that there can be two keys which gets mapped to the same location. Here you can see that all the keys have been mapped to the different locations, but it may be that two keys may be addressing to the same location. So in that case, a collision happens. So when you choose the hash function, you need to be very sure that this hash function has less collisions in this table, right? And what is a hash function? I can give you an example of a hash function, very simple example. It's not like any hash function will be like that. Suppose a function is like f int f, and this is the function which returns. If you give some value, it returns. Suppose you give 389, or you can say you give int k and you provide 389. Then in that case, it will return 389 divide percentile 10. So this is an example of a hash function. What it will return? Percentile means this is a C code basically. I have written a C code, but ultimately you know that what does this percentile return? This percentile returns the remainder after dividing this 389 by 10. Okay, so the remainder will be 9, which means the index will be 9. So whatever will be the index 9, at that place the particular value will be stored in that example that I have just discussed. Similarly, there can be many functions. This was the simplest hash function, and this kind of hash functions are not very much useful that I have shown you. I just showed you to have a feel like how do they look like, how do they work. Okay, so based on these hash functions, you can understand that what we are going to achieve. When we are using the hashing, then we are making our searching efficient. The value that we are going to store in the database, or not in the database, maybe in database, maybe in some other structure, whatever we are going to do, if we are using hash functions, then we are going to make the searching efficient and fast. Okay, so the hash functions are used for that purpose. So let me show you one thing. Let me just come here. K is equal to 10, hash 10.45, and if I print K, then you can see that this is some large value in negative, and this is a unique value for 10.45. No matter how many times you use it, L is equal to hash 10.45. If you use a hash function, this hash function has been provided by the library of Python. So if you print L, then also you will get the same value. So no matter how many times you are hashing the same value, either it's in form of something like m is equal to 10.45. In fact, here I have done the same thing. So let me just do something like kk is equal to hash, and then let's pass m, and then let's see what does this print returns. Print kk. What does this print do? So you can see that all the values that have been taken, whether they have been stored in a variable or directly passed to this hash function, they are giving me the same hash value, and based on this value the system, the Python, the algorithm which is storing our values in the local structures, like if you are using list, if you are using tuple, if you are using anything like set. In that case, if you are using hash, then in that case that hashing will store the values in that manner only. And when you will search for that value, then in that case it will simply use the hashing, not the linear expressions, to find out where your data is stored. Okay, so like suppose if I have, let me just clear it all and just close this and open our, or you can say open our new cell or restart the cell. Okay, so this is a new cell, and then L is equal to, suppose I have taken 12, 13, 45, right? So this is the list. And if I find, like, if 12 in L, print available in list, right? So you might have seen the use of in the earlier videos. So if 12 is available inside this list, then it will print available in list. Okay, so let's just go and run it, and you can see that available in list has been printed. But the thing is that if this list is too big, right? Suppose if I write like L is equal to not only this, I'm just going to print like this, and then if I write if 89 in L, and then if I print value available, okay, otherwise what I'm going to do, I'm simply going to print, oh, it's invalid syntax, so let me just copy it again. Anyways, you understand what I'm trying to explain here. So if I run it, it will not print anything because 89 is not here. But in this case, what will happen, like the value 89 will be searched in a linear fashion, which will take time, right? But if you have used the hashing for this L, right, if you have hashed this L, then what will happen? In that case, if you will search 89 in L, then in that case what will happen, that it will be searched based on the hash function. Whatever hash function will return, based on that it will try to find out the particular index in the table structure which it will internally maintain, and based on that it will simply find out the value. So that will obviously take lesser time, right? So that is where the hashing is used. But one thing you must need to understand, and one thing you must need to always remember, that list is a mutable sequence. You know about the mutable sequence? Mutable sequence are those which can be changed over the time. Like the values inside this list, they may be changed, they may be removed at some point of time. So you should not any data structure, here I have taken list for example, you should not you should not use the hashing with any data structure which is mutable. You should use only when your data structure is non-mutable, like tuples, right? You should use it for tuples, not for the list. Suppose I have taken a tuple t is equal to 1, then 2, then 3. Okay, now if I do hashing hash t, okay, so in this case now I have hashed the t, this t has been hashed. Now if I find if 3 in t, print yes. Okay, so yes has been printed, but there is a difference. If you have not hashed it, it would have been done in the linear fashion, right? But if you have done it using the hashing, then in that case, when you were using this, if 3 in t, in this case, when this was executing, at that time it was not going it linearly. to search the value 3. It was using the hash table to find out the value 3, where it has been stored, at what index it has been stored. Okay, so this was the use of hashing. Now let us see how we can use it with the user defined data types, or you can say the user defined types, classes. Okay, we are going to create our own classes and we will see that how we can use it. Here I'm going to write a class name is student. Let us put it simple, student. This is my class. And if you remember from the previous videos where I have discussed about the class and the init, the constructor things, all these things where I have discussed, you might have seen. You can go there and you can see that how these things are used. So you can do like this, def underscore init. It simply works like a constructor, but it is not actually a constructor. I have already explained it. So here, suppose I am going to store name, SSN, and the address of the student where he lives, right? So here what I'm going to do, self dot name is equal to name, self dot SSN is equal to SSN, and self dot ADDRESS is equal to ADDRESS. Okay, so now we will write, this is the constructor where you can find, where we can pass the name, SSN, and address, and the first argument that you pass, you don't need to pass the first argument. The first argument is that the object itself. This is representing the object itself, just like this pointer in C++, right? So here, what is like self.name, self.ssn, these are the values which are available inside the student, and these are the values that you will provide, and these will be copied, right? Now, when we are doing the hashing, then we will do the hashing based on the unique value. So you can see that here the name, SSN, and the address, all these three numbers, among all these three numbers, only the SSN will be a value which is unique, and all the other things like name and address can be changed. Even in some cases, names can also be changed by the students or for the by the people. Okay, so let us simply write a function. Simply write a function def for sorry for the interruption. I had to close the door. Self. Just give me one more some moment. Sorry for the interruption. Okay, so now we have to do one more thing. Def SSN. Here you need to write like hash, and you have to hash it on the SSN. You need to pass the self here, and you need to return the hash self.ssn. Okay, and then based on this hash value, sometime we need to compare the two objects. So to compare the two objects based on the SSN, you also need to define one more variable, one more function, equal. Here you need to pass the self and the other object. You need to pass one more object to which you will compare, and you will do something like this: return self.ssn is equal to other.ssn. Okay, so let's just do this thing. Now we are going to create two students, records for two students. S1 is equal to student 1, 2, 3. This will be the SSN number 445, and then 5, 6, 7, 8. This is the SSN number, and the address is Noida. Okay, and there is another student. S2 is equal to student, and the name still remains same, but he has changed his address. 1, 2, 3, 4, 4, 4, 4, 5, and then 5, 6, 7, 8. And then what is there? Like it's Noida. Not Noida, it's Bihar. So I have been moved to Bihar, right? So now we are doing the hash here. When we do the hash here, then this function will be called, and it will do the hash on the SSN only, right? So based on the SSN, if you have updated the record of a student based on the SSN, and if you are going to S1 is equal to S2, use this one. And if you want to print, like, if both are same, then you need to print both records are of same student, and then else print both records are not of same student. Okay, so let's see what happens. Run this module. Before that, I need to save it, so I'm just going to save it in C drive. Where is my program? Yeah, Python. So here I'm just going to save it like testfile1.py. Okay, so I have just updated it, and here double equal, here it should be like double equals. Okay, so let me just run it. Okay, so here it's okay, SEFL. So this is the blunder I have done. SEFL self dot address is equal to address. Now if I run it, both records are of same student. You can see that both these records have been displayed as same, because I have done the hashing on this, the SSN number. Now there is one more thing. If S1 is S2, I'm just going to remind you about the difference between this. S1 is equal to S2 and S1 is S2. Print both are same objects, else print both are not same objects. Okay, so you can see that in this case, it is not showing you the correct value. In fact, it's not showing you that both the objects are same. It is saying that both the objects are not same objects. Why is this? Why is this? This is because S1 and S2 both have different addresses. And when we talk about the S1 is S2, when we use is, then in that case, the objects are compared, the addresses are compared, the address of the objects are compared. Not this thing will be compared. This thing will be only be compared because I have written this thing, and this will be compared based on the hash. So that is why it is working here. So this is the way you can use the hashing with your application. And in the next video, we are going to discuss something more about the hashing, like various different functions, various functions which have been provided by the hashing library, which has been provided by the Python. So we will discuss one by one them, all of them. So in the next video, we will discuss few more things about the hashing, and then we will close it. So for today, that is it. Please like, subscribe my channel, and please share my video. And sorry for the interruption for today.